Children, let us continue the chapter Work and Energy. Now let us discuss about the conversion of energy from one form to another. Can we convert energy from one form to another? We find in nature a number of instances of conversion of energy from one form to another form. That is, one example is in photosynthesis. In photosynthesis, plant use solar energy and converts that solar energy into chemical energy. Converts solar energy into chemical energy. Photosynthesis in plants converts solar energy into chemical energy using electrons and protons from water. So, what is photosynthesis? Photosynthesis is the process plants use to convert energy from the sun into usable energy for their cells. Plants use the light energy of the sun, carbon dioxide and water to make glucose and oxygen. Here, the energy of the sun is captured and stored in the bonds between atoms in glucose molecule. So, in photosynthesis, solar energy is converted into chemical energy. Now, let us write one example of the conversion of energy from one form to another form is photosynthesis. You take examples here, examples for the conversion of energy. Right? Examples for the conversion of energy from one form to another. One form to another. Right? First example, that is in photosynthesis, in photosynthesis plants converts solar energy into chemical energy. Solar energy into chemical energy. So, that is one of the example for the conversion of energy from one form to another form that takes place in nature. And also air movement of air is also because of solar energy. That solar energy is converted into kinetic energy or mechanical energy. Know that how does air move from one place to another? Air moves because the sun generates heat on the earth. This causes hot air. Hot air rises creating wind. The air, which is made up of oxygen and carbon dioxide and many other gases, is carried from one place to another place in the form of wind. Air moves from one place to another place due to the different temperature and pressure conditions on the earth. So, wind is also caused by the solar energy. So, it is also conversion of solar energy into wind. So, you can say that wind is a form of solar energy and also here wind is caused by the solar energy. So, here solar energy is converted into wind energy. Therefore, it is a, right? Therefore, it is a conversion of solar energy. Conversion of solar energy. And also you know that the fuels such as coal, petroleum, etc. are also the conversion of the solar energy. One more example you can give that fuels such as coal and petroleum are also forms of solar energy. And you know how coal and petroleum are formed? Coal and petroleum are formed as a result of degradation of ancient plant life which lived millions of years ago. These dead plant matter started to pile up, eventually forming a substance called peat. Over time, heat and pressure from geological process transformed these materials into coal. Similarly, petroleum also formed by the microorganisms which are buried under the sea. So, this petroleum and coal are formed by the plants and microorganisms. So, they are also converted from solar energy, because you know that the plants and microorganisms, any living being, lives with the help of solar energy. So, solar energy is present in the plants and animals, and as they converted into coal and petroleum, you can say that fuels are also conversion of solar energy. So, let's say that solar energy is also in the form of fuel energy. Fuel energy, or you can take fuels like coal and petroleum. Coal and petroleum. And also in the water cycle. In the water cycle, there is a conversion of energy. That is also there is a conversion of solar energy. You know that here, due to the heat of the sun, water bodies evaporates to form the clouds, and rain forms. Again rain enters into the water bodies. Again water bodies evaporates. In this way water cycle takes place. That is also because of solar energy. So, take water cycle. Water cycle is the example for the conversion of energy. Conversion of energy. And also you can say that these are the energy conversion taking place in the nature. Yeah, photosynthesis, that is take place naturally, and winds and fossil fuels, water cycle, these are the example for the conversion of energy which takes place in the nature. Many human activities and the gadgets we use involve conversion of energy from one form to another form. Can you give the examples for the gadgets to convert energy from one form to another form? So you can give, first one is fan. You know that fan converts electrical energy into mechanical energy. Electrical energy into mechanical energy. Similarly, you know, here dynamo. Dynamo converts mechanical energy into electrical energy. So here you can write converts what? Mechanical energy into electrical energy. Electrical energy. And also, so you write motor. So motor converts electrical energy into mechanical energy. We are using the motor in mixer, grinder, fan, washing machine, etc. In all the devices, motor converts electrical energy into mechanical energy to run the machines. And also, let us take the cell. Cell converts chemical energy into electrical energy. You know the battery cell that converts chemical energy into electrical energy. Electrical energy. And again you can use solar cell. Solar cell converts solar energy into electrical energy. So you take converts solar energy into electrical energy. Electrical energy. In radio, which energy is converted into which energy? In radio, electrical energy is converted into sound energy. In radio, which energy is converted into which energy? Electrical energy is converted into sound energy. Know that sound is also form of energy. Electricity is also form of energy. Electrical energy is converted into sound energy in radio. Here you know that electrical energy which travels along the wires that connect a power plant to our home. The electrical energy used by the radio is converted into sound energy. Sound is another form of energy, and it is also form of kinetic energy because it is an air in motion. Sound travels through the air. So next let us take TV. In TV, which energy is converted into which energy? In TV also electrical energy is converted into sound energy and light energy. So here in TV, which energy is converted into which energy? Electrical energy into light energy and sound energy. Light energy and sound energy. Light energy and sound energy. In radio, electrical energy is converted into sound energy. In television, electrical energy is converted into light energy and sound energy. Now about the conversion of energy in human activities. Human being eats food and the food is having chemical energy. The food which is eaten by human being is stored in the form of fat, and that energy is converted into mechanical energy, that is nothing but kinetic energy, by doing some activities. So human being doing work is nothing but the product of force and displacement in the direction of the application of the force. So as W is equals to F into S, and in all the activities the energy, chemical energy is converted into muscular energy and thereby kinetic energy. So, chemical energy by the food is converted into muscular energy and by doing some activity and work, that energy is converted into mechanical energy. Now about the law of conservation of energy. You know that one form of energy can be converted into another form. So, energy can be changed from one form to another form. What happens to the total energy of a system during or after the conversion of energy? Whenever energy gets transformed, the total energy remains unchanged. For example, you can take here, you know that dynamo converts mechanical energy into electrical energy. Dynamo converts mechanical energy into electrical energy. The total mechanical energy before the conversion is equals to total electrical energy after the conversion. Here, the mechanical energy, how much was there? That is equals to electrical energy after it converts. Similarly, motor converts electrical energy into mechanical energy. That electrical energy is equals to mechanical energy. Electrical energy is equals to mechanical energy, and there is no any change in the energy. Here, energy remains same before the conversion and after the conversion. The quantity of energy remains. So, in all the cases, before the conversion and after the conversion, the energy remains same. The quantity of energy remains changed. That is, whenever energy gets transformed, the total energy remains unchanged. So, that is the law of conservation of energy. Then, what is the statement of law of conservation of energy? Energy can only be converted from one form to another. It can neither be created nor destroyed. The total energy before and after the conversion remains the same. That is the law of conservation of energy. Energy can neither be created nor be destroyed. So it can only be converted. It can only be transformed. During the conversion, total amount of energy before the conversion and after the conversion remains same. Now let us write the law of conservation of energy. So then what is the law of conservation of energy? You write that energy can only be transformed from one form to another. It can neither be created nor destroyed. So write energy can only be transformed. Only be transformed from one form to another. From one form to another. It can neither be created nor destroyed. It can neither be created nor destroyed. Nor destroyed. The total energy before and after the transformation always remains constant. Always remains constant. So, according to law of conservation of energy, energy can only be transformed from one form to another. It can neither be created nor destroyed. The total energy before and after the transformation always remains constant. So, here you can write that the total energy before conversion or before transformation equals total energy after transformation. The total energy before the conversion equals total energy after the conversion. The law of conservation of energy is valid in all situations and for all kinds of transformation. It is valid for all situations and all kinds of transformation. So that is about the law of conservation of energy. Now let us take one example. Let an object with mass m. Consider an object with mass m is made to fall freely from certain height h. Here it is an object of mass m is made to fall freely from a height h. Then you know what is its potential energy? Its potential energy is, that is, EP is equals to what? M into G into H. At that start, the potential energy is M into G into H, that is maximum, and kinetic energy is 0. At that height, kinetic energy is 0 because the object is at rest. So, you know that the total amount, that is 0 because its velocity is 0, then the total energy of the object thus is equals to what? That is total energy is equals to what? mgh only when it is at a height h. The total energy of the object is equals to mgh plus 0, that is equals to mgh. As it falls, its potential energy converts into kinetic energy. Consider here there is a object at certain height. Object at certain height h. Here is a object, its mass is m and it is at a height h. So its potential energy is m into g into h. At this height, its potential energy is m into g into h, and kinetic energy is what? That is 0. Now when it is made to fall, what happens? Its motion starts, so its potential energy changes into kinetic energy. As it falls, its potential energy will change into kinetic energy. If its velocity is v at a given instant, then you know that the kinetic energy is equals to what? Kinetic energy is equals to what? Half mv square. At certain instant, if it is moving with a velocity v, then its kinetic energy is half mv square. As the fall of the object continues, the potential energy goes on decreases and it converts into kinetic energy. The potential energy would decrease while the kinetic energy would increase. When the object is about to reach the ground, the height becomes equals to 0 and velocity becomes maximum. Then the kinetic energy also becomes largest and the potential energy becomes least, and the sum of the potential energy and the kinetic energy of the object would be same at all points. Here, if it reaches this height, then also the sum of the potential energy and kinetic energy is constant. Here, but what happens? Part of the potential energy converts some part of the kinetic energy, but the sum remains constant. And at the time of reaching the ground, the potential energy becomes approximately 0 and kinetic energy becomes maximum. So you can say that at any instant, that is mgh plus half mv square is constant. Mgh plus half mv square equals constant. That is, the sum of the potential energy and kinetic energy is constant. The sum of kinetic energy and potential energy of an object is its total mechanical energy. Its total mechanical energy. We find that during the free fall of the objects, the potential energy decreases. The decrease in potential energy at any point in its path appears as an equal amount of increase in kinetic energy. Here, the decrease in the potential energy is equals to the increase in the kinetic energy. So you take decrease in potential energy equals what? Increase in kinetic energy. That is, at any instant, that is, decrease in potential energy is equals to increase in kinetic energy. So we find that during the free fall of the object, the decrease in potential energy at any point in its path. So here, at any point in its path, at any point in its path, decrease in potential energy equals increase in kinetic energy. Here the effect of the resistance on the motion of the object is ignored. There is thus a continued transformation of gravitational potential energy into that is kinetic energy. Continuously, here what happens? When the object is made to fall from certain height, continuously there is a change in the potential energy. There is a transformation of the potential energy into kinetic energy. Children, you do an activity. An object of mass 20 kg is dropped from a height of 4 meter. Fill in the blanks in the following table by computing the potential energy and kinetic energy in each case. So, first let us take the height. H equals what? 4 meter. And it is given that mass is given M. M is equals to 20 kg. And also here the acceleration due to gravity is given, that is the value of G is 10 ms to the power of -2. Now let us find out the potential energy and kinetic energy, and you know the formula for the potential energy, that is EP equals M into G into H, that equals M is 20, G is 10 into 4, you will get 20 into 10 is 200. 200 plus 4 is 800 joules. 800 joules. So you can write it is 800 joule. Then what about the kinetic energy? You know that when it is at a height 4 meter, it is dropped from a height of 4 meter. So at a height 4 meter, its velocity is 0. So at h equals 4m, e is equals to 0. Therefore, you can say that k is equals to half mv square, or mu square by 2 is equals to half into 20 into 0 square. You will get 0. So you write that is 0 joule, and then you will get 800 plus 0 is equals to 800 joules. 800 joules. Next, the second. Here h is equals to 3 meter and the remaining are same, that is m is equals to 20 kg and g is same, 10 ms to the power of -2. Then you will get EP is equals to the formula is m into g into h, that is m is 20 and G is 10, H is 3. So you will get 20 into 10 into 3, that is 200 into 3 is 600. Now let us find the kinetic energy. To find the kinetic energy, velocity is required at h3. Here the distance travelled is s is equals to 4 minus 3 is equals to 1 meter. Then you know the formula v square minus u square is equals to 2gs. Here u is 0. So you can have v square minus 0 is equals to 2 into 10 into 1. Then you can have v square is equals to 20. So Ek equals half mv square, that equals half into v square, directly you can write, that is half into m is 20 kg, same value here, m is 20 kg you take, that is 2, v square is 20, then 2 ones are 2 tens are, you will get 200 joules. So second you write here, if at the height 3m, EP is 600 and Ek is 200. So write 600 joule, it is 200 joule. Then you will get 600 plus 200 equals 800 joules. Then you take at the height 2 meter. Then you take h equals 2 meter. And here G is same, that is M you take next, M is same, that is 20 kg and G is same, that is 10 ms to the power of -2. Here you find potential energy EP, M into G into H, M is 20, G is 10 and height is 2. So it is 20 into 10 into 2, you got 400 joules. 400 joules. Then EK equals, here first you get V value. Here at a height at h is equals to 2m. Here again the distance traveled is, if you start from this one, again you take here, you can take this height only. If you take this initial height is 4, from here to here the distance traveled becomes, so S becomes 4 minus 2, 2. So again you can take u is equals to 0, that becomes easy for you. V square minus u square equals 2gs, that is v square minus 0 is equals to 2 into 10 into distance is here 2. Then it becomes v square is equals to 2 into 10 into 2 is 40. Then write the formula. Ek equals half mv square, that is half into 20 into 40. So that is 2 ones are 2 tens are, you will get 400 joule. So right, this is 400 joule, this is also 400 joule. Then you will get 400 plus 400, 800 joules. 800 joules. The next, take at h is equals to 1 meter. The next height is 1 meter. At h is equals to 1 meter. Then same, m is equals to 20 kg, g is equals to 10 ms to the power of minus 2. Again you write EP is equals to m into g into h. M is 20, g is 10, h is 1. Then you will get 200 joule. Now at h is equals to 1m, the distance travelled becomes 4 minus 1, 3 meter. Then you write again v square minus u square, starting that is equals to 2gs. V square minus 0 is equals to 2 into 10 into, that becomes 3. So v square you got 2 into 10 into 3, 60. Then Ek equals half mv square, that equals half into m. M is how much? That is 20, and v square is 60. So it becomes 2 ones are 2 tens are, that equals 600 joules. 600 joules. Then you write this is 200 joules. This is 600 joules. So you will get 200 plus 600 equals 800 joules. Then just above the ground. Just above the ground means h becomes equals to 0. Take just above the ground. That is at h equals 0. Then m is seen. M is equals to 20 kg and g is equals to 10 ms to the power of minus 2. So here EP is equals to m into g into h. M is 20, g is 10 and h is 0. H is 0. So it becomes 0. 0 joules. And what about kinetic energy? Here you can have that at h is equals to 0. You take v square minus u square is equals to 2gh. Here the distance travelled becomes 4. The distance is here 4 meter to 0 distance cut means 4 minus 0 is equals to 4 meter. That is s is equals to. So you take v square minus, again you take 0, 2 into 10 into 4. Then V square equals 2 into 10, 20, 24 is 80. 80 meter per second, or 80 you can take here. Then Ek is equals to half mv square. That is half into m is 20. V square is 80. So it becomes 2 ones are 2 tens are. You got 800 joules. So here potential energy becomes 0 and kinetic energy becomes maximum when it reaches the ground. So it is 0 joule. It is 800 joule. So it becomes 0 plus 800 equals 800 joules. So here what you can observe, the sum of potential energy and kinetic energy remains constant throughout its path. Here see, when it is at a height 800, this is 800 plus 0, you got 800 joules. When at a height 3 meter, 600 plus 200, again it is 800. Next, at a height 2 meter, 400 plus 400, it is 800 joules. Again 200 and 600 at a height 1 meter, and at a height 0, that is just above the ground. Here you take 0, this is 800 you will get, and totally it is 800 joules. So the sum of potential energy and kinetic energy remains constant. So here, according to law of conservation of energy, energy can be transformed from one form to another form. It can neither be created nor be destroyed, but the total energy remains same. Total energy before and after this transformation remains the same. We learned that in nature, the conversion of energy takes place from one form to another. What would have happened if teacher had not allowed the transformation of energy? If nature has not allowed the transformation of energy, there is a view that life could not have been possible without transformation of energy. Life could not have been possible without transformation of energy, because you know that photosynthesis will not take place, wind will not be there, and fuels will not be formed, and water cycle will not be there. So all these are the transformation of energy that is allowed in the nature.